Hello everybody, getting ready to do pre-calculus math today, lesson 4.3 part 3. This is my email for specific requests, instructional materials, videos, PowerPoints, note-taking guides, etc. 4.3 part 3, 42 points here of classwork, and you got 2 points here goes in your notebook. And then today, starting right off here with classwork applications. So many applications of trigonometry involve a process called solving of right triangles. In this type of application, you're usually given one side of a right triangle and one of the acute angles and are asked to find one of the other sides. Or you were given two sides and are asked to find one of the acute angles, like in this situation here. So you're either given this side, you're given what if that is a hypotenuse, and then the angle of elevation, we're given an angle, and usually there's a right angle down here for that. So in example 8, the angle you are given is the angle of elevation. So the angle from the horizontal upward to the object is the angle of elevation. In other applications, you may be given an angle of depression, which represents the angle from the horizontal downward, either upwards or downwards to the object. So this would be an angle of depression here. So these are problems that usually trigonometry are known to solve, right triangle trigonometry anyways. So using trigonometry to solve a right triangle, a surveyor is standing 50 feet from the base of a tree. Here's your surveyor. Here's your 50 feet from the base here of a large tree. The surveyor measures the angle of elevation. So your angle of elevation will be right here to the top of the tree at 71.5. So when they shoot a line up here from an instrument, it's 71.5 degrees. How tall is the tree? So knowing how far the surveyor is back from the tree, here's our y here and here's our x, you can see that tan 71.5 would be up over adjacent. So here's our up, which we're trying to find, and then our adjacent, y over x. So where x equals 50 and y is the height of the tree. So the tree the way we'd find this would be y here, y equals x tan 71.5. So our x is 50. We know our x would be 50. 50 tan 71.5. So when you plug that into your calculator, we come up with 149.43 feet is what your calculation should come out to be. So in our first guide practice here, draw a right triangle that gives a visual representation of the problem. So we have a situation here, a 6-foot person walks from the base of a streetlight directly toward the tip of a shadow cast by the streetlight. When the person is 16 feet from the streetlight and 5 feet from the tip of the streetlight shadow, the person's shadow starts to appear beyond the streetlight shadow. So how would we solve this situation here to find how tall the streetlight is? So we need to draw a sketch here of this problem that gives a visual representation of the problem, show the known quantities, and use a variable to indicate the height of the streetlight. So to do that, first of all, here's our sketch here. So we have a street light here, which is our height. The person's 16 feet back from the street light, and 5 feet from the tip of the street light shadow. So you're 6 feet away, and you're still, but yet 5 feet from the tip of the shadow. So here's our total shadow length would be 16 plus 5. So using a trigonometric function to write an equation involving the unknown quantity, which is the height of the street lamp. So tan theta would equal 6 over 5, and then tan theta would equal h over 21. So we have two triangles. Remember, we have a 6 and a 5 op over adjacent, and then this will be our op over adjacent of the total triangle. You have two triangles. So when this 6 over 5 here will equal h over 21. So we need to find h in this proportion here, because those triangles are in proportion to each other. So you set up a proportion. This would be the function that you would use, because the triangles are proportional. So what would the height of the street light be? So when you do your cross multiplication here, or 5 times h equals 6 times 21, that would be the way I would do it. They solve for h here, so they multiply both sides by 21, 6 times 21 over 5, and you get 25.2 for h here. That'd be the way they would do it. See, 5h, that'd be the same thing, but they just solve for h here. And when they get 25.2 would be the height of your street light by setting up this proportion here. Okay, so using trigonometry to solve a right triangle, example 9. You are 200 yards from a river. So here you are, you're 200 yards from the river. Rather than walking directly to the river, you walk 400 yards along a straight path to the river's edge. So here's your path here, 400 yards. Find acute angle theta. So you need to find this angle here. And you started here, and we're assuming that you're a direct right angle from the river. So you know this angle. Do we know this angle? Well, not sure about that. We have a triangle. We know that much. So find the acute angle theta between the path and the river's edge. But we have two distances here. So if we have two distances, we should be able to solve for your two angle measures there. Does it say up here what the angle measures there? No, it doesn't. You can see that the sine of the angle theta, so the sine would be the opposite over the hypotenuse, and this would be your hypotenuse here. See that the sine of angle theta is sine theta equals opposite over hypotenuse. 200 over 400 would equal 1 over 2. So that would be the function value. Now you should recognize that theta equals 30 degrees. If we come up with this function value here for a sine on a right triangle, then you should know that it is a 30-degree angle and also by punching that into your calculator, you'll come up with that as well. So a zip line, let's go into a guided practice now, knowing that we're all qualified to solve something like this. A zip line steel cable is being constructed for a reality television competition show. The high end of the zip line is attached to the top of a 50-foot pole, while the lower end is anchored at the ground level to a stake 50 feet from the base of the pole. So we're 50 feet away on the ground level from a 50-foot pole. So find the angle of elevation of the zip line. So here is a diagram, 50 feet away, and it starts 50 feet high, and then here's your zip line here. Quite an exaggeration of it, but nevertheless a sketch. Sketches are invaluable for solving word problems. So find the number of feet of steel cable needed for the zip line. So we need to find the length here of our hypotenuse to do that. We find the angle of elevation first. Oh, okay. So we'll find the angle of that elevation. So tan theta equals 50 over 50. Tan theta. So here's our angle of elevation. It'll be down here. We know this is a right angle here. So we're trying to find this angle here. So tan theta is 50. It'll be opposite over adjacent, 50 over 50, which equals 1, which we know that tan of 1 is 45 degrees. So this is a 45-degree angle there. Find the number of feet of steel cable needed for the zip line. So we got some valuable information we can use to find the length of this cable. So length 2 is 50 squared plus 50 squared equals 2 times 50 squared. So we're going to use the Pythagorean theorem here to solve this. So the length squared equals 50 squared plus 50 squared, which equals 2 times 50 squared, equals L equals 50 times the square root of 2. That would be the length of the steel cable. So a contestant takes 6 seconds to reach the ground from the top of the zip line. At what rate is the contestant moving down the line? At what rate is a contestant dropping vertically? So a contestant takes 6 seconds, so it travels this distance in 6 seconds. And then, so this is feet here, 50 times square root of 2 feet. So we plug this in down here over 6 seconds. So we're going to try to find this per second. So we factor out a 2 here, and we get 25 times square root of 2 over 3 feet per second. That's your rate down the zip line. So that's our rate. At what rate is the contestant dropping vertically? So to find a vertical drop per second, we have 50 over 6 equals our vertical rate here. And when you simplify this, 50 over 6, you get 25 over 3 feet per second. We know that it takes 6 seconds for the contestant to go 50 feet. So assuming that's a constant rate, we can assume that the contestant on average is going 25 over 3 feet per second. Or that's a little bit more than 8 feet per second, which is moving pretty good, I have to say. So that would be by using this number here, up here. See, 50 feet up here is the total drop is 50 feet. And then the length up here is this amount here. But the vertical drop is 50 feet. And it takes 6 seconds to go 50 feet. So it'd be 25 over 3 feet per second. Okay, an oblique entry here. Example 9, you're able to recognize that theta equals 30 degrees is the acute angle that satisfies the equation sine theta equals 1 over 2. Suppose, however, that you were given the equation sine theta equals 0.6. And we're asked to find the acute angle theta because sine 30 degrees equals 1 over 2, which equals 0.5, and sine 45 equals 1 over the square root of 2, which approximates to 0.7071. You might guess that theta in this situation up here at 0.6 lies somewhere between 30 and 45. 0.6 would be between these two values here. In a later section, you will study a method by which a more precise value of theta can be determined. Okay, let's go into another example here. Solving another right triangle. Find the length C here. So again, this is our hypotenuse here on a right triangle. Here is our right triangle. We got 4 feet here of height, and we got 18.4 degrees here on this angle over here. Find the length C of the skateboard ramp shown. So you can see that sine 18.4 from this angle, 18.4, which would be our opposite over our hypotenuse, would be 4 over C, according to this diagram here. So the length of the ramp is C, our length here. C equals 4 over sine 18.4. You see how that comes out here. When we solve for C, and move our C over here and then divide out our 18.4, we get C equals 4 over sine 18.4. So to solve for our length here of our ramp, which is this length here, outlined in yellow, to do that, we continue with our calculation here, and we have 4 over 0.3156, and then that comes out to 12.67 feet. So by using sine, we used sine of this angle here, we knew the angle measure, and then we knew the height, and we needed to find our hypotenuse here. So we used our sine function to come up with 12.67 feet by using this calculation. Okay, another guided practice here. A biologist wants to know the width W of a river. Here's our river here. So this is our W. In order to properly set instruments for studying the pollutants in the water, from point A here, the biologist walks upstream 100 feet and sights to point C. So he looks back to point C where the crossing is here, sights back to that. From this sighting, it is determined that theta equals 58 degrees. So from this sighting here, it's calculated that this is a 58 degree angle here that the biologist is looking back to see. How wide is the river? Verify your result numerically. So to do that, we're going to use our tan function here. And what we're going to do, how wide is the river? We need to find this. So we are looking here from our 58 degree, look back here to see. So tan 58, which is opposite over adjacent. So it will be W over 100. So when we solve for W here, W equals 1, this 100 will move over here, 100 tan 58 degrees, and then when you crank that out of your calculator, you come up with 160 feet for that. So that is 4.3 part 3 pre-calculus math. If you need any materials or tutoring, email me here and I'll get back to you. Thank you very much.